Hello and welcome to my video demonstration of the native VLANs lab. In this lab we're going to explore the native VLAN, why we have it, what it is, and how it's used. Now in original Ethernet standards there were no switches, so everything was hubs. Every packet was did not have an 802.1q tag, we did not have traffic. Anything that went into the hub came in and it went out just the way it came in. Now when they came up with switches, we were able to segment our networks using VLANs and trunking. But what happened if you had a network of hubs and you could replace everything instantly? Maybe you had budget constraints where you couldn't replace all your hubs each in one fiscal year. Maybe you just had time constraints and you couldn't replace everything in one weekend. So when they made 802.1q trunking, they made it backwards compatible so it could support hubs, which would introduce untagged frames. And down here, if you look at Alpine Linux 4, you'll see that if it's connected to a hub, there's no way that frame's going to be tagged. Frames coming in from the devices connected to switches like AL1, Alpine Linux 1, it comes into the switch as an 802.3 Ethernet frame, but when it leaves the trunk converts it, adds that VLAN information, and makes it an 802.1q trunk with the VLAN tag inside there. So let's go ahead and get started. To get the recording short, I've gone ahead and built the lab on GNS3. And the first step I have to do is I have to go into my 5 host devices and put IP addresses on them. So I'm going to go ahead and start a console to all devices, and we'll start putting IP addresses on them. So we'll start with, let these load up a sec. Boom. Okay, so we've got them all started. I'm going to just widen this out a little bit and I'll start putting IP addresses on my host devices. So I'm going to go into Alpine Linux 1, IP address add 192.168.10.1/24 device Ethernet 0. And then I'm going to have to do the same for all the other devices. Linux 2 is 10.2. Go on to Alpine Linux 3. Alpine Linux 3 is on the 20 network, 20.3/24. Go on to Alpine Linux 4. 20.4/24 device, and the last one, Alpine Linux 5, IP address 20.5/24. Okay, so I've got my addresses add. It's always good to double check just to make sure, or I can just even go back here and just double check and make sure I had the address right. I got the right prefix length. 23 goes to Alpine Linux 3. 10.2 goes to Alpine Linux 2. And 10.1. Okay, so I've got my addresses right. So now the next step I need to do is I need to go in and configure my switches. I'm going to have to create my VLAN assignments, and then I'm going to have to make that trunk. So we'll start on S1, and I'll get my prompt by hitting the enter key, and then type admin for the username. Enable to enter privileged exec mode, configure terminal to go into global config mode, and now I can start configuring things. So the first thing I'm going to do is I'm going to create my VLANs. And I could name it, I'm not going to in this example, and then I'll create VLAN 20. Now let's go in and I need to make port 2 and 3 access ports and assign them into VLANs 10 and 20. So interface Ethernet 2, and it's going to be an access port, switch port, mode, access. And then switch port, access, VLAN 10. And then let me go over to Ethernet 3, interface Ethernet 3. I can use the up arrow to bring back switch port mode access, use the up arrow again to change VLAN 10 to VLAN 20. So I'll put ports 2 and 3 in VLANs 10 and 20. Last thing I want to do is go into interface Ethernet 12, and I'll make that a trunk. Switch port mode trunk. So that's S1. I've got some verification commands if I wanted to check. I can do show interface status, and that shows all my ports and the VLAN assignments, and it confirms that Ethernet 12 is a trunk. And I can also do show interface trunk, view all my trunking interfaces, and I can see that Ethernet 12 is indeed trunking. So now let's go on to S2 and do the same thing. Admin, and I need to go, actually I should have named it too. I always like to name my devices, because then when I'm looking at the prompt I know exactly what device I'm connected to, and it keeps me from making mistakes by clicking on the wrong tab. So enable, and then I will name it, and then I need to create my VLANs. And create VLANs 10 and 20. Now let's go assign some ports to VLANs. Interface Ethernet 2 and switch port mode access. Switch port access VLAN 10. Ethernet 2 is in VLAN 10. And then I can go into interface Ethernet 5. So I'll put Ethernet 2 in VLAN 10, I'll put Ethernet 5 in VLAN 20. The next step is I got to make that trunk, so I'll go into interface Ethernet 12. Okay, so I've configured trunking, and the next step I need to do is I need to assign the native VLAN. I need to tell these ports Ethernet 12 and Ethernet 12 over here what VLAN to treat untagged traffic. And by untagged traffic, I mean this device, Alpine Linux 4, he's connected to the network, but since he's connected to this hub, that hub's not going to tag the traffic before it sends it to S2 or S1. So we need to tell S1 and S2 what to do with straight up 802.3 Ethernet frames, because they're expecting traffic to all be 802.1Q, which includes that VLAN ID field. So we'll go into it on both devices, and I'll say switch port trunk native VLAN 20. And I can do the same thing on S1. Switch port trunk native VLAN 20. Okay, so now I've assigned the native VLAN on ports 20, and what that's going to do is that's going to tell this switch that if you get anything untagged, then you go ahead and you only send those frames out ports on VLAN 20. And actually it also tells the switch anything coming in on VLAN 20 is going to go out this trunk link untagged. So let's take a look at that. So the first screen capture we're going to take a look at, well, the first thing we need to do is we need to send some pings. So let's start some pings. I'm going to start on Alpine Linux 1, and I'm going to create a ping to 10.2. I'm going to ping from Alpine Linux 1 going across the trunk, and I'm going to ping Alpine Linux 2 on 192.168.10.2. So ping 192.168.10.2. And I'm going to just let this ping run forever because I want to perform packet captures and look at these frames. So now let me go to Alpine Linux 3. And I'm going to ping 192.168.24. I'm going to ping Alpine Linux 4. So I'm going to ping from here to here. 192.168.20.4. And we'll let those pings go on for a while. So now that I've got some pings going on, I've got some traffic going through, now I can do some packet capture. So let me just minimize this, and to do a packet capture, I can simply highlight over a link, right click on it, and I want to take a look at how these frames look when they're going across this trunk. So I'll click OK, I'll start the packet capture, and now I'm going to just do a filter. So I'm going to type ip.source, ip.src, and IP source is going to be equals. Double equals is for comparison, is what IP, the double equal signs, means a lot of times. I'm not assigning something, I'm comparing two values, 192.168.10.1. So now I want to look at all IP packets sourced from Alpine Linux 1. Now all I got to do is double click on it. Doesn't matter which one I do, they're all really the same messages. And notice here I have an 802.1q frame being sent, and it includes the VLAN field right there for me. So now let's change and take a look at those frames going from Alpine Linux 3 to Alpine Linux 4. They're going across this trunk link, but let's see how they look to the hub and how that all works. So now I'll just change this filter to 20.4. Now when I filter for those, it's really easy to double click and open up any frame. I don't have to worry about them scrolling through. And notice here how these frames originating from Alpine Linux 3, they're going into the switch, they're leaving this trunk, but the switch knows that since these come in on a VLAN that's part of the native VLAN, that it's not going to put a VLAN tag here. And that's what's going to signify to Ethernet 12 that Alpine Linux 3 and Alpine Linux 4 are both on the same VLAN, the native VLAN. So anyway, I hope this helps explain native VLANs, why we have them, and now that you probably don't see hubs on a network, this was designed to interact with hubs at a time when hubs were the predominant networking device and these were backwards compatible. But now that we've done that, we can't really change it now, so we have a native VLAN, and there probably are still hubs out there somewhere. So anyway, I hope this helps explain the lab for you, and thanks for watching.